Most of us carry a quiet pride in our galaxy, the Milky Way, the great wheel of stars we call home, the container of everything we have ever known. But two things about it are almost never said out loud. It is the smaller of the two large galaxies in our corner of space, outmatched by a neighbour you can find on a dark night as nothing more than a faint smudge, a spiral of 1 trillion suns wider than our own. And the famous collision between the two of them, the one every documentary promised in 4.5 billion years, was quietly downgraded in 2025 to something closer to a coin flip. Even our galaxy's grand ending, it turns out, was told with far more confidence than the truth could carry. Tonight we are going to find out how small and how uncertain our real place in the universe actually is. So settle in, hit subscribe if you're new here. Because by the end of this, even the size of your own galaxy will feel like something you have to hold a great deal more lightly. Now, let's slowly ease into this. Part 1. The smudge you almost never notice. There is a smudge of light in the autumn sky that almost no one has ever really looked at, and it happens to be the most distant thing your eyes can see without any help at all. Most people walk beneath it their entire lives and never once find it. It hides in a quiet corner of the sky, inside the constellation we named Andromeda, and it does nothing to announce itself. It is faint. It is soft. It looks, when you first catch it, like a flaw in your own vision, a little smear you could wipe away with a blink. And yet the moment you understand what you're seeing, that small blur becomes the largest and the oldest thing you have ever looked at with your unaided eyes, and the first quiet crack opens in the comfortable idea that you have any real sense of your own size. Let me put you there, because this is a story that only works if you can feel it rather than simply hear it. Imagine you're standing outside on a cold, clear night, far from any town, in the kind of darkness that has almost disappeared from the modern world. Your eyes have had 20 minutes to adjust, and the sky above you has slowly filled in, not with a few bright points, but with a fine powder of stars scattered edge to edge. The air is sharp in your throat. Somewhere far off a dog goes quiet. You tip your head back and you find the little lopsided W of the constellation Cassiopeia, and you use it as an arrow, and you let your gaze slide down and across until it lands on a small, dim oval of light that is not a star, because it does not sparkle, and it does not sit at a single point. It is a patch. It is a breath of grey against the black. You hold your thumb up at arm's length, and you notice that this faint patch is actually wider than the full moon, though only its core is bright enough to catch, and you are looking, right now, at another galaxy, so far away that the light entering your eye left its source 2.5 million years ago, before your species existed in the form it wears tonight. Notice something about how you had to look in order to see it at all, because it is a small lesson that will grow through the night. You cannot find Andromeda by staring straight at it. The very centre of your vision, the part you aim at anything you want to see clearly, is nearly blind to something this faint. To catch the smudge, you have to look slightly to one side of it, and let it register in the corner of your eye, where the cells that see in near darkness are gathered. And then, as if by a trick, the oval swims quietly into being just off the point where you are aiming. Look directly at it, and it dissolves. Look a little away and it returns. The largest thing your eyes can reach is not only faint and easy to miss, it actively resists the hard, direct stare and gives itself only to the patient, sideways, unhurried kind of attention. There is something almost instructive in that, on a night meant for slowing down. The biggest things are often the ones you have to stop straining toward before you can see them at all. Consider too how long that faint patch waited to be understood, because the waiting is part of the humbling. Human beings have been looking up at it, on and off, for as long as there have been human beings, and for almost all of that time it was simply there, a little cloud, unremarked or misfiled. The Persian astronomer we mentioned, Al-Sufi, wrote it down more than 1,000 years ago as a small cloud, and he was among the most careful observers of his age. For the several centuries after him, it stayed a small cloud in everyone's notes, an entry in a list, a minor curiosity. Not one person looking at it, in all those long generations, had any idea they were staring at a separate island of 1 trillion suns, because no one yet possessed the concept that such islands could exist. The knowledge we now carry so casually that this is another galaxy larger than our own, is astonishingly young. And the smudge did not change to earn it. It hung there, patient, the same faint oval through thousands of years of human looking, waiting for someone to build an instrument fine enough and grow a mind ready enough to finally ask how far away a thing must be to look so small. That last fact deserves a moment of stillness, because it changes what looking even means. The light you're catching tonight did not leave last week or last century. It left before there were people. It has been crossing the darkness between that galaxy and this hillside for 2.5 million years, moving the entire time at the fastest speed anything can move, and it has arrived tonight to end its enormous journey inside the small wet darkness of a single human eye. You did not travel to it. It came to you, and it has been coming the whole time your ancestors were learning to walk upright, to speak, to bury their dead, to wonder what the lights in the sky might be. When people say the night sky's old, this is what they mean, in the most literal way. You're not seeing Andromeda. You're seeing a message from Andromeda's distant past, and the galaxy that sent it has moved on, changed, aged, in all the time the message was in flight. We are going to spend this whole quiet night with that little smudge, because it turns out to be a doorway. On the far side of it lies the real subject, which is not a galaxy at all. The real subject is you and me and the true size of the ground we stand on inside the known universe. Most explanations of cosmic scale try to overwhelm you with bigness all at once, a fire hose of enormous numbers until the mind simply goes numb and stops feeling anything. We are going to do the opposite. We are going to start with one thing you can actually see, this faint oval in the constellation Andromeda, and we are going to follow it, patiently, one honest step at a time, outward and outward, until we arrive somewhere genuinely unsettling and, I think, genuinely beautiful. And we're going to earn every step so that when we reach the strangest conclusion of the night, you will not have to take it on faith. You will have walked there yourself. Consider how easy this object is to miss, because the ease of missing it is part of the point. Its brightness, measured on the scale astronomers use, sits at about magnitude 3.4. On that scale, smaller numbers mean brighter objects, and the faintest thing a healthy human eye can catch under perfect darkness sits at about magnitude 6. So Andromeda is comfortably within reach of the naked eye, brighter than the dimmest stars you can see, and still, almost nobody sees it, because you have to know exactly where to look, and you have to be somewhere truly dark, and fewer of us ever are. From a city, it is simply gone, washed out by the glow of streetlights into the same blank orange nothing that swallows most of the sky. An entire galaxy, a trembling oval of 1 trillion suns, erased by a parking lot. There is already a small lesson hiding in that, about how much is real and present and utterly unnoticed, all around us, all the time. The people who first wrote this object down did not know what they were describing. A Persian astronomer named Al-Sufi noted it more than 1,000 years ago as a little cloud. For centuries afterward, stargazers catalogued it as a smear of nebulous light, one of many faint fuzzy patches that dotted the sky, and they filed it away with the others, assuming it was some nearby cloud of glowing gas inside our own system of stars. The charts labelled it eventually as Messier 31, the 31st entry in a famous list of fuzzy things that were emphatically not comets. For most of human history, in other words, the largest thing anyone could see with their own eyes was mistaken for a minor local haze. The truth of what it was would not arrive until the 20th century, and when it did arrive, it did not just reclassify one smudge. It shattered the size of the entire universe in a single stroke, and it did so by starting exactly where you are standing tonight, with a faint patch of light and a stubborn refusal to look away from it. Hold on to the image of that smudge, the one you could hide behind your thumbnail, because we are going to return to it again and again through the night, and each time we return it will have grown. Right now it is just a soft grey oval, easy to overlook, the kind of thing your eye slides right past. By the end of tonight, that same oval will hold 1 trillion suns, the fate of our own galaxy, and a strange kind of mirror in which you will see both the far past and the far future at once. That is the journey. It begins small, with something dim and quiet and almost invisible, and it does not stay small for long. So let yourself settle for a moment in the simple strangeness of the starting point. The most distant object a human being can see, with the naked eye, is not a special blazing beacon. It is a whisper. It is the faintest thing that still counts as visible, sitting right at the edge of what the eye can do, and you have to work to find it, and once you find it you're looking further into space and further back into time than you will ever look again without a machine to help you. There is a quiet humility built into that fact. The universe does not put its largest visible thing in lights. It tucks it into a dim corner and lets it be missed by nearly everyone for nearly all of history, and it waits to see whether anyone will bother to ask the obvious dangerous question, what is that really? And how far away does it have to be to look so small? Part 2. The Colossus hiding in a blur. The question of what that smudge really was hung over astronomy for a long time, and the answer, when it finally came, made the universe hundreds of thousands of times larger overnight. For most of the 19th and early 20th centuries, serious astronomers argued about the faint spiral smudges scattered across the sky. One camp said they were clouds of gas inside our own galaxy, which was assumed to be the entire universe, a single island of stars floating in an endless void. The other camp suspected something far more disturbing, that each faint spiral was itself an entire separate galaxy, a whole other island of stars so absurdly far away that it shrank to a smear. If the second camp was right, then our galaxy was not the universe. It was one of countless galaxies, and the cosmos was unthinkably larger than anyone had dared to say out loud. The argument was settled in the middle of the 1920s, and it was settled using our smudge. An astronomer named Edwin Hubble, working with the largest telescope in the world at the time, on a mountain in California, managed to pick out individual stars inside the Andromeda smudge. Among them he found a particular kind of star that pulses, brightening and dimming on a steady, reliable clock. These stars, called Cepheid variables, have a hidden property that had been worked out by Henrietta Leavitt a decade earlier. The speed of their pulsing reveals their true brightness, and once you know how bright a star truly is, and you compare that to how bright it merely appears from here, the difference tells you exactly how far away it must be, because light fades with distance in a precise and knowable way. Hubble timed the pulsing of a Cepheid in Andromeda, calculated its real brightness, compared it to its faint appearance, and arrived at a number so large that it ended an argument that had run for a century. Andromeda was not inside our galaxy. It was nearly 1,000,000 light-years away by his first estimate, and far beyond even that by the corrected measurements that followed. It was another galaxy. The universe had just grown 1,000-fold, and it has never stopped growing since. The moment of that discovery carries a human drama worth pausing on, because it shows the same pattern we keep meeting, a tiny creature overturning the size of everything from a single faint clue. Only a few years earlier, in 1920, two respected astronomers had stood up in Washington and formally debated whether the spiral smudges were nearby clouds inside our galaxy, or far-off separate galaxies, and the matter had ended unresolved, a genuine open question at the frontier of knowledge. Then Edwin Hubble, examining his photographic plates of Andromeda, spotted a star that brightened and dimmed on a steady clock, timed it, and understood what it meant. The story goes that he crossed out a note he had written on the plate and scrawled a single triumphant word beside the star, and that when he sent his result to one of the men who had argued the spirals were nearby, that astronomer called it the letter that destroyed his universe. Nothing physical had changed. A star had been pulsing in Andromeda for millions of years, its light already most of the way here. But in the instant one human being grasped what that pulsing meant, the universe every person alive had believed in was quietly replaced by one hundreds of thousands of times larger. That is the strange power of the small thing we are, and we will return to it once the smallness has done its work. Let me give you a fuller picture of the object that pulsing star revealed, because its very structure is part of why it took so long to read. Andromeda is turned steeply toward us, tilted only about 22 degrees away from perfectly edge-on, so we do not see its spiral face laid open the way we see some other galaxies. We catch it at a sharp slant, an oval rather than an open wheel, its arms foreshortened and overlapping, its lanes of dust stacked into a confusing blur. It took decades, and eventually telescopes that see in infrared light, which slips through the dust that stops ordinary light, to map its true shape. When the Spitzer Space Telescope studied Andromeda in the infrared, it revealed a bright central bar of stars, with two main spiral arms winding out from the ends of that bar and threading through an enormous ring of dust and gas, a ring where much of the galaxy's new star formation is gathered. The arms are not the clean, sweeping ribbons of a textbook spiral. They break into segments and knots and short spurs, an untidy, worked-over structure, the written record of a galaxy that has been jostled and fed by its companions across billions of years. The modern number is even more staggering than Hubble's first attempt. Andromeda sits about 2.5 million light-years from us. That is the figure to hold, because we're going to feel its weight from many different angles tonight. 2.5 million light-years means that light, the fastest thing in existence, moving at about 186,000 miles every single second, needs 2.5 million years to cross the gap. And here is the first genuine tilt of the floor beneath you. That dim little oval, the one that looked like a smudge you could rub off the glass, is not small. It only looks small because it is so far away that its true size has been compressed almost to nothing. In reality, it is one of the largest single objects you will ever perceive. Let the real dimensions arrive slowly, because they are worth savouring. Andromeda is a giant spiral galaxy, a flattened, rotating city of stars with graceful arms winding out from a bright central bulge. Its disk stretches something like 220,000 light-years from edge to edge. To put that in human terms is almost impossible, but let us try. Light that crosses the gap from here to the moon in a little over a second, light that crosses from the sun to the Earth in about 8 minutes, would need 220,000 years merely to travel from one side of Andromeda to the other. And packed inside that spinning disk are not millions of stars, not billions, but something on the order of 1 trillion stars. 1 trillion. If you tried to count them one per second, without ever sleeping or stopping, you would need more than 30,000 years just to finish counting, and by the time you were done, the galaxy would have changed beneath your counting. Now set that trillion-star Colossus against the thing you have always, quietly, thought of as everything. Our own galaxy, the Milky Way, the great wheel of stars that contains the sun and the earth, and every human being who has ever lived, holds somewhere between 100 billion and 400 billion stars, and spans roughly 100,000 to 120,000 light-years across. By almost every measure that matters to the eye, Andromeda is the larger of the two. It carries more stars. Its light output, its total brightness, runs about 25% greater than our galaxies. It is not a rival across town. It is the bigger neighbour, and it is the nearest bigger neighbour we have. This is the moment the story stops being a pleasant fact about the night sky and starts becoming personal, because you have just met for the first time the shape of the whole night's argument. You began by looking at something you assumed was small and unremarkable, a faint grey blur, and the closer you looked, the larger it became, until it turned out to dwarf the very thing you thought of as the entire world. That reversal, from tiny to enormous, from ignorable to overwhelming, is going to happen again and again tonight, at every scale we climb to. Each time you will think you have found the edge of how small you are, and each time the floor will drop again. There is a strange comfort in dwelling on Andromeda's grace before we let the scale frighten us, so let us stay with the object itself a little longer. It is a barred spiral, which means its central region is not a simple round ball, but an elongated bar of stars, from whose ends the spiral arms unwind. Its arms are not perfectly smooth ribbons. When we map them carefully, especially in the infrared light that cuts through the dust, they appear as segments and knots and irregular stretches, a great ring of gas and dust threaded through with the bright clumps where new stars are being born. The whole thing is tilted steeply to our line of sight, turned nearly edge-on, only about 22 degrees away from being a perfect knife edge, which is why it looks like an oval rather than a full open spiral, and which is part of why untangling its true structure has taken a century of careful work. Andromeda is also, in a sense, older and calmer than our galaxy, and that difference will matter later when we start wondering what might live there. Its stars are on average more ancient. Many of them are more than 7 billion years old, formed in an earlier, more furious era of the galaxy's life. Today, Andromeda has settled into something more sedate. It forges new stars at a rate of only about 1 sun's worth of new material per year, while our own galaxy, more restless and more actively creative, is spinning up new stars at 3 to 5 times that pace. Andromeda is the elder of the two, the one that did most of its building long ago, and now turns more slowly through its middle age. It is larger, brighter, older, and it is coming very slowly toward us. But that last part is a thread for later. For now, simply sit with the reversal you have just lived through. A smudge you could hide behind your thumbnail turned out to be a spinning wheel of 1 trillion suns, 220,000 light-years wide, larger than the entire galaxy you live in. You did not know it was there. You could not have picked it out of the sky without instruction. And it has been hanging over every night of your life, over every night of every human life, quietly enormous, quietly ignored. If the largest thing your eyes can reach is this easy to overlook, and this much bigger than you assumed, then a natural and slightly uncomfortable question begins to form. Where does that leave the galaxy you thought was everything, and where exactly does that leave you? Part 3. The Smaller of Two Galaxies. The uncomfortable truth about our galaxy is one that almost no one says plainly, so let us say it plainly here, in the dark, where it is easier to hear. We're not the biggest thing in our own neighbourhood. The Milky Way, the galaxy that holds everything and everyone you have ever known, is the smaller of the two great galaxies in our local corner of the universe. Andromeda is bigger. Andromeda has more stars, spans a wider disk, and pours out more light. For all of human history, we have told stories with our galaxy at the centre of them, the grand wheel of stars that is our home and our whole context. And it turns out that even at this modest local scale, one single step above the Earth, we have already been outsized by a neighbour we can barely see. I want to be careful and fair here, because the two galaxies are, in one important respect, more evenly matched than the star counts suggest. When astronomers weigh galaxies, they do not just count the glowing stars, they measure how the galaxies rotate and how they pull on their satellites, and that reveals the enormous amount of unseen material, the dark matter, that makes up most of any galaxy's true mass. By those measurements, the Milky Way and Andromeda are roughly in the same weight class, each somewhere around 1 trillion times the mass of the Sun once the dark matter is included, with Andromeda's total mass and our own overlapping within the uncertainties. So this is not a story of a giant and a dwarf, it is a story of two comparable giants. But by the measures the eye and the mind care about, the number of stars, the width of the disk, the sheer output of light, Andromeda is the elder, larger sibling, and our galaxy is the younger, smaller one. And that alone is enough to begin dismantling a quiet assumption most of us have carried without ever noticing we carried it. Now let us find your actual address inside that smaller galaxy, because it makes the humility sharper. You do not live at the centre of the Milky Way, you live far out in the suburbs. The Sun sits about 27,000 light-years from the galactic centre, roughly halfway out toward the edge of the star-filled disk, on a minor, unremarkable spiral feature that astronomers sometimes call the Orion Spur, a small bridge of stars that is not even one of the galaxy's main arms. Picture the great pinwheel of the Milky Way from above, its bright bar and its grand sweeping arms, and then look for us, and you will find us nowhere near the brilliant crowded centre, but off to one side, on a faint connecting strand between two larger arms, a good long way from anything that could be called important real estate. We are not downtown. We are not even in a proper neighbourhood. We are on a quiet side street, in the smaller of the two big cities, in this particular region of space. This pattern of discovering that we are not where we assumed we were is one of the oldest and most reliable movements in all of science, and it always goes the same direction. Every single time humanity has measured its own position more carefully, it has found itself less central than it had believed. We once knew, with total confidence, that the Earth sat motionless at the centre of everything, with the Sun and stars wheeling around us. We were wrong. We learned that the Earth orbits the Sun, and consoled ourselves that at least the Sun was central. We were wrong again. The Sun is far out on a spiral arm of a galaxy so large that its centre is 27,000 years of light away. We assumed then that our galaxy was the whole universe. Wrong once more, as Andromeda's true distance proved. At every step, the more precisely we located ourselves, the smaller and more off-centre our position turned out to be. There is no reason yet tonight to think that process is finished. Here is a quiet aside I want to plant now gently, so that it can grow through the rest of the night. Not only are we small and off-centre, we are, from any real distance, effectively invisible. Everything humanity has ever done, every city we have lit, every signal we have broadcast would be undetectable from Andromeda with instruments like our own. The Sun itself, our home star, the source of all our warmth and light, could not even be picked out as a single point from that distance. We will return to what that invisibility really means much later, when we are standing in our imaginations on the far side of that gap and looking back. For now, just let the seed sit there. The galaxy that overshadows us cannot see us at all, and neither in truth could anyone else out in the wider dark. We are not merely small, we are unseen. There is a real grief hidden in this part of the story, and it is worth naming rather than rushing past, because it is the first of the night's genuine emotional weights. Most of us carry, without ever examining it, a certain pride in the Milky Way. It is ours. It is home. In our art and our language, it is the grand backdrop of everything, the river of light across the sky, the container of all our meaning. And in the space of a few honest measurements, that home has become the smaller of two, sitting off in a corner, holding a species that cannot be seen from next door. The security of our galaxy, its size, its centrality, its significance, comes quietly loose in your hands. It is not a violent loss. It is a soft one, the kind you might not even notice happening until you reach for the old certainty and find it is no longer there. And the strange thing, the thing this whole channel is built around, is that this loss does not have to hurt. Held the right way, it can open into something better than the comfort it replaces. But we are not there yet. Tonight we let the old certainty come loose first, and we sit with the smallness before we find what is on the other side of it. There is a rhythm to these demotions that is worth naming, because noticing the rhythm is part of making peace with it. Each time, humanity found a new thing to be central to, just in time to lose it. When the Earth stopped being the centre of everything, we consoled ourselves that it was at least the centre of the Sun's family, the special world where all the important things happened. When that comfort thinned, we held on to the Sun as the centre of the whole star system, the hearthstone of the galaxy. When the Sun turned out to sit far out in the suburbs, we retreated to the galaxy itself as the entirety of creation, the one island of stars. And when Andromeda proved there were other islands, larger ones, we were left holding the last and smallest consolation of all, which is simply that we are here to notice any of it. Every earlier comfort was a place. This final one is not a place. It is an act, the act of understanding, and it is the only one, as we will see by the end, that the measurements can never take away from us, because it is the very thing doing the measuring. Think about what has happened beneath that unchanging smudge in just the sliver of time our species has existed. Andromeda's light arriving tonight left 2.5 million years ago, and in the time it has been travelling, our ancestors went from small upright creatures chipping simple stone tools to a species that split the atom, walked on the moon, and charted 1 billion stars. Whole civilizations rose and fell in the final few thousand years of that light's journey, a rounding error at the very tail of its flight, and the smudge did not register any of it, because the smudge cannot register anything. All of recorded human history, every name you have ever learned, every empire and song and sorrow, happened in the last blink of that light's crossing, on a world too faint to be seen from the place the light set out from. We are not only small in space, we are brief, and we are unseen, and the largest thing we can look at has no way of knowing we are looking back. Consider, too, that we did not have to know any of this. For nearly the entire span of human existence, people lived and died believing their world was the world, their sky, the whole sky. They were not tormented by their cosmic smallness because they had no idea it existed. The knowledge that we are the lesser of two local galaxies, adrift on a minor arm, invisible to our neighbours, is extraordinarily recent. It is younger than photography. It is younger than the light bulb. For 100,000 years a human being could stand under Andromeda, see that same faint smudge, and feel like the centre of creation. We are among the first people who cannot honestly feel that anymore, because we are the ones who measured the truth. That is a heavy inheritance. It is also, though it does not feel like it yet, a kind of privilege, and by the end of the night I want you to feel why. So we have taken one step up from the Earth to the galaxy, and already the ground has shifted twice. Our galaxy is the smaller of the two giants here. Our own position within it is far from the centre, out on a minor arm in the suburbs of starlight, and we are, from the vantage of our own nearest large neighbour, completely invisible. That is a great deal to absorb from a single faint oval in the autumn sky. But we have only taken one step. There are many more to climb tonight, each one pulling the camera further back. Before we start that climb outward, though, there is something we need to look at more closely, something that complicates the entire picture of our smallness, because the same tiny, off-center, invisible creatures who just learned how little they are also did something that, when you really consider it, should not be possible at all. Part 4. The grain of dust that weighs a galaxy. Here is the fact that should not fit alongside everything we have just said, and yet it is true. We have weighed the black hole at the centre of Andromeda. Sit with how absurd that sentence is. We are a species that has never sent a single human being farther than our own moon. A 3-day trip in cosmic terms, a hop across the front yard. We cannot be seen from Andromeda. Our loudest signals fade to nothing long before they get anywhere near it. And yet, from 2.5 million light-years away, using nothing but the faint light that trickles down to us and the machinery of patient thought, we have measured the mass of the dark, invisible object hiding at that galaxy's exact centre. We know it weighs somewhere between 100 million and 230 million times as much as the Sun. We're a grain of dust that has learned to weigh a galaxy, and I want you to hold that phrase, because it is the other half of tonight, the half that will eventually answer the smallness. Let me show you how far this reaches, because the detail is genuinely hard to believe. In 1991, the Hubble Space Telescope turned its eye on the very centre of Andromeda, and it found something nobody expected. The core was not a single bright point, it was double. There were 2 distinct concentrations of light at the galaxy's centre, separated by only about 4.9 light-years, which at that enormous distance is an almost impossibly fine detail to resolve, like distinguishing 2 candle flames held a few inches apart from the other side of a continent. Astronomers name the 2 concentrations P1 and P2. The dimmer of them, P2, sits at the true centre of the galaxy and marks the location of the supermassive black hole. The brighter one, P1, is slightly off to the side, and its brightness posed a genuine puzzle. Why would the brightest point of a galaxy's core not sit at the core's true centre? The leading answer is a thing of real elegance, and it tells you how precisely we have been able to reason about a place we will never visit. The idea, worked out by the astronomer Scott Tremaine in the 1990s, is that P1 is not a separate object at all, but an illusion of motion. Imagine a disk of stars looping around the central black hole, not in neat circles but in stretched, eccentric, egg-shaped orbits. A star on such an orbit moves fast when it swings close to the black hole, and slow when it drifts out to the far end of its loop. Because the stars linger at the far, slow end of their orbits, they pile up there, spending more of their time in that region, and from our vantage that pile-up glows as an extra bright spot, offset from the true centre. P1 is a traffic jam of starlight at the far turn of 1 million eccentric orbits. There is a competing idea too, that the strange double core is the leftover scar of an ancient collision between 2 black holes, whose merger and recoil reshaped the swirl of stars around them. We are not certain which story is right, but notice what we are arguing about. We are debating the orbital shape of stars around a black hole in another galaxy, and we are doing it well, with real evidence on each side from a grain of dust that cannot even be seen from the place in question. You might reasonably ask how anyone can weigh a black hole they cannot see, in a galaxy they can never visit, and the answer is a small marvel of indirect reasoning. A black hole betrays its mass through its grip on the stars around it. The heavier the hidden object, the faster the nearby stars must move to hold their orbits against its pull, exactly the way a heavier sun would whip its planets around more quickly. So astronomers gather the combined light of the crowded stars near Andromeda's centre, spread that light into its component colours, and read, in the subtle stretching and squeezing of the spectral lines, how fast those stars are racing. From those speeds, and the laws of gravity worked out on this small world centuries ago, the mass of the unseen thing at the centre falls out as a number. That is how we come to know that the black hole in Andromeda weighs between 100 million and 230 million suns. We never saw it. We watched how it moves the stars around it, from 2.5 million light-years away, and we inferred the weight of a darkness. The competing explanation for the double core is worth hearing too, because it is stranger than the first, and because our honest uncertainty between the two is itself a kind of integrity. In this version, the 2 bright points are the aftermath of a violent event. Long ago, the reasoning goes, Andromeda may have swallowed another galaxy that carried its own central black hole, and the 2 black holes spiraled together and merged, releasing a storm of gravitational waves, ripples in the fabric of space itself. If that merger was even slightly lopsided, it would have kicked the resulting black hole to one side and stirred the surrounding stars into the off-center, double-lobed shape we now see. We cannot yet say for certain whether the double nucleus is a calm illusion of lingering orbits or the slow healing scar of an ancient collision, but sit with what it means that we can even frame the question. We are weighing gravitational wave recoil against orbital geometry, arguing about the buried history of another galaxy's center, from a speck of dust that the galaxy in question cannot detect at all. The reach does not stop at the core. We have counted Andromeda's globular clusters, the ancient tight-packed spheres of hundreds of thousands of ancient stars that orbit a galaxy like bees around a hive, and we have tallied about 460 of them. We have singled out the largest, a monster cluster called Male 2, or simply G1, which holds millions of stars and shines about twice as brightly as Omega Centauri, the grandest globular cluster in our own galaxy. We have looked closely enough at G1 to notice that its stars come in more than one distinct population, which hints that it may not be an ordinary cluster at all, but the stripped-down, surviving core of an entire small galaxy that Andromeda swallowed and digested billions of years ago. We have identified more than 20 dwarf galaxies orbiting Andromeda as satellites, and we have watched two of the closest, called M32 and M110, closely enough to read their histories in their light. M32 appears to be the dense, battered remnant of what was once a much larger galaxy, most of its outer stars torn away by Andromeda's gravity, leaving only a stubborn core, a galaxy reduced to a nub. M110 still carries lanes of dust and signs of relatively recent star formation. We have even traced faint streams of stars wound through Andromeda's outer halo that are the shredded remains of other small galaxies pulled apart in ancient encounters, their stars now strung out like debris along the paths of their destruction. Every single one of those measurements was made from here, from the smaller galaxy, from the minor arm, from the invisible grain of dust. We built instruments that could gather the trickle of ancient light and squeeze information out of it that our own eyes could never reach. We worked out the mass of an unseen black hole from the way stars swirl around it. We read the ages of stars from the colors of their light. We reconstructed the violent history of a galaxy's cannibalism from faint threads of stars almost too dim to detect. This is the strange doubleness at the center of tonight's whole story, and I want you to feel both halves of it at once, because neither is the full truth alone. We are physically negligible, unseen, confined to a single small world we cannot leave, and we are, at the same time, the thing in this story that understands. The grain of dust has weighed the galaxy. Both things are true. Hold them together, because we are going to need both of them at the end. Let me make our physical smallness concrete with one more number, so the contrast has teeth. The farthest that any evidence of humanity has travelled into space is not our spacecraft, which have barely left the sun's own neighbourhood. It is our radio and television broadcasts, the sphere of stray signals that has been leaking off the Earth and expanding outward at the speed of a light since we first started transmitting, a little under a century ago. That means our entire detectable presence in the universe is a bubble roughly 100 light-years across, and it is not even a strong bubble. Those signals spread out and weaken as they travel, sinking into the natural static of the cosmos, so that even a modest distance out they become almost impossible to distinguish from noise. 100 light-years, fading. Now recall that Andromeda is 2.5 million light-years away. Our loudest shout has crossed less than 1/20,000th of the gap to our nearest large neighbour, and it is already dissolving into silence. The mind that weighed Andromeda's black hole lives inside a whisper 100 light-years wide, in a universe where the nearest big galaxy is 2.5 million light-years off. That is the tension of the entire night, laid out in two numbers, so we hold, now, two facts that seem to belong to different stories. We are so small and so quiet that the galaxy overshadowing us has no way of knowing we exist, and we are so capable of understanding that we have measured that galaxy's hidden centre, counted its clusters, and reconstructed its ancient crimes. A grain of dust that can weigh a galaxy. Keep that phrase near you. Because now that we understand what Andromeda is, and how strangely well we know it, we have to turn to the one fact about it that has frightened and fascinated people more than any other. That larger, older, overshadowing neighbour is not sitting still out there. It is moving. And for as long as we have been able to measure it, it has appeared to be moving toward us. Part 5. The collision we were promised. For most of the last century, astronomers believed they knew exactly how the story of our galaxy would end, and the ending they described was a collision with the very galaxy we have been watching all night. The evidence for the approach is written into Andromeda's light. When an object moves toward you, the waves of light it sends are squeezed slightly shorter, shifted toward the blue end of the spectrum, and when an object moves away, its light is stretched longer toward the red. Nearly every galaxy in the universe shows a redshift, because the universe is expanding and almost everything is drifting apart. But Andromeda is one of the rare exceptions. Andromeda's light is blue shifted. It is not receding. It is coming toward us, closing the gap along our line of sight at roughly 110 kilometers every second, which is nearly 400,000 kilometers an hour. The largest thing your eyes can see is falling toward you, and it has been for as long as we have known how to measure it. The classic picture built from that motion was dramatic and specific. Somewhere around 4.5 to 5 billion years from now, the two great galaxies of the Local Group would meet. They would not so much crash as pass through and into each other, their stars threading past one another while their clouds of gas slammed together and lit up in a furious burst of new star formation. Over hundreds of millions of years they would swing apart, then fall back, then merge again, until the two graceful spirals had been stirred together into a single enormous ball of stars, a giant elliptical galaxy. Astronomers even gave the merged galaxy playful names, mixtures of the two that made it, and they modelled what the sky would look like from Earth as it happened, with Andromeda swelling across the night, filling the heavens, tearing slowly into ribbons of light over eons. It was one of the grandest and most repeated predictions in all of popular astronomy. Our galaxy had an appointment, and the date was on the calendar. Naturally, people wanted to know what would become of us, of the Sun and the Earth, in that collision. And here the answer is stranger and gentler than you might expect, because galaxies are mostly empty space. When two galaxies merge, their stars almost never actually hit each other. The distances between stars are so enormous compared to the sizes of the stars themselves that two galaxies can pass straight through one another, and hardly a single star will strike another. What changes is the choreography. The gravity of the encounter flings stars onto wild new paths. The simulations of the classic collision suggested that our solar system had about a 50% chance of being thrown outward, to a region perhaps 3 times farther from the new galactic centre than we sit today, and roughly a 12% chance of being ejected from the merged galaxy altogether, flung out into the darkness between galaxies to drift alone. Notice that even in the grandest catastrophe our galaxy faces, the individual stars mostly survive untouched. It is not a story of fire and destruction. It is a story of rearrangement, of being quietly moved or quietly cast out, while the sun itself burns on, indifferent, through the whole affair. To feel why the stars almost never collide, shrink the whole picture down to something you can hold in your hand. Imagine the sun reduced to a single grain of sand. On that scale, the nearest other star is not a few grains away. It is another grain of sand roughly 4 miles off, with nothing but empty room between them. That is the true texture of a galaxy. A scattering of sand grains separated by miles of darkness, in an enormous, mostly empty hall. Now take 2 such halls and run them straight through one another. The grains sweep past, and the chance that any 2 actually touch is almost nothing, because the gaps between them dwarf the grains themselves. This is why the merger of 2 galaxies, for all its grandeur, is not a demolition. It is 2 clouds of sand passing through each other, rearranging their patterns, while the individual grains sail on untouched. The sun would very likely survive the whole encounter without a scratch, flung onto a new path perhaps, but burning steadily through all of it. What would change across those hundreds of millions of years is the sky. If the classic merger happened, and if there were still anyone on Earth to see it, they would watch Andromeda swell slowly, across generation after generation, from a smudge to a smear to an enormous tilted spiral filling a large part of the night, its arms stretching and distorting as the 2 galaxies pulled at each other, new stars igniting in bright knots along the tortured lanes of gas. It would be one of the most magnificent skies any world could ever offer, and it would unfold so slowly that no single lifetime could perceive the motion, only the frozen frame of an ongoing collision, held overhead for millions of years at a time. Hold that image for a moment, because we were promised that sky. It was, for decades, presented as the settled future of our galaxy. And it is exactly that promised future which has recently quietly come undone. And notice, even inside the grand version, where the real weight of the story lives, it is not in the collision, it is in the distance the collision has to cross. For two galaxies to meet at all, they must first close a gap so enormous that the closing takes billions of years even at the tremendous speeds galaxies move. The grandeur of the merger is really the grandeur of the emptiness it must swallow. So before we watch the certainty of that ending fall apart, I want you to feel the emptiness directly, not as the backdrop to a collision, but as the thing itself, the immense and almost unbelievable gulf that separates us from the one galaxy near enough to call a neighbour. Before we go further, I want you to feel the distance to Andromeda in your body, not as a number, but as a lived impossibility, because it will make everything that follows land harder. Imagine we launched a spacecraft toward Andromeda today, moving at the speed of our fastest space probes, something like 17 kilometers every second. That is astonishingly fast by human standards, fast enough to cross from the Earth to the Moon in a few hours, fast enough that no person has ever travelled at anything close to it for long. Now hold that speed steady and point it at the smudge. Watch the sun behind you shrink. In a few thousand years it fades from a blazing star to an ordinary point of light, indistinguishable from the others. In 100,000 years you have crossed the gap to where the nearest stars are, and Andromeda has not visibly grown at all. 1,000,000 years pass. 10 million. 100 million. The smudge is perhaps, just perhaps, a little larger, and the clock keeps running, past 1 billion years, past 10 billion, past the current age of the entire universe, and still you are not there. At 17 kilometers per second, the crossing to Andromeda would take something on the order of 40 billion years, roughly 3 times the age of the universe as it stands today. You would be travelling for longer than everything has existed, and you would still not have arrived. That thought experiment is worth sitting inside quietly for a moment, because it converts the distance from a fact you know into a fact you feel. Even light, the fastest thing there is, needs 2.5 million years to make the crossing, measured from here and measured from there alike. For light, the trip is 2.5 million years each way, no matter how you frame it. There is no vehicle, no technology, no imaginable improvement that turns Andromeda into a place we could visit. It is not far the way another city is far, or another continent, or even another planet. It is far in a way that removes it permanently from the category of places, and leaves it only in the category of things we can see. We can measure Andromeda's black hole, and we can never, ever go there. That gap between what we can know and what we can reach is going to widen into something enormous by the end of the night. And yet, for all its unreachable distance, this was the galaxy that was supposedly coming to rewrite our own galaxy's future. That was the settled story, repeated in every documentary and every classroom for decades. The Milky Way and Andromeda are destined to merge. Our galaxy will die as a spiral and be reborn as an elliptical. The appointment is 4.5 billion years out, and it is certain. That certainty was comfortable in its own strange way, because even a catastrophe, if it is certain and far off, gives a kind of shape to the future. It tells you where the story is going. It lets you feel that at least the ending is known, even if you will not be there to see it. Here is where I have to tell you that the certainty has come undone, and that the undoing happened very recently, and that it is one of the cleanest examples I know of how science actually works, and of how our confident stories about ourselves keep shrinking under better measurement. Because in the last couple of years, astronomers went back to that famous prediction with better data than anyone had ever had before, and what they found was not a firmer date for our doom. What they found was that the collision we had all been promised, the one appointment on our galaxy's calendar, may not happen at all. The single most repeated fact about the future of the Milky Way turns out to rest on a measurement so delicate that once you account for everything honestly, the ending flips from a certainty into something much closer to the toss of a coin. And the reason why reveals something not just about Andromeda, but about how carefully and how humbly we have to hold every story we tell about our own place in the universe. Part 6. The Night the Certainty Dissolved. In June of 2025, a team of astronomers led by a researcher named Tilsawala published a study in the journal Nature Astronomy, and its title said the quiet part out loud. It was called simply, No Certainty of a Milky Way and Andromeda Collision. These were not fringe skeptics or attention seekers. They were careful scientists using the best data humanity has ever gathered, combining measurements from the Hubble Space Telescope with the extraordinary star-mapping mission called Gaia, which has charted the positions and motions of more than 1 billion stars with a precision no earlier generation could have dreamed of. And when they fed all of that into their simulations, running the encounter forward not once but many thousands of times to account for every uncertainty, the famous collision simply stopped being inevitable. In their results, the two galaxies merged within the next 10 billion years only about half the time, and the classic head-on collision in the next 4 to 5 billion years, the one on every documentary and every timeline, happened in only about 2% of their simulations. The number that came back was 2%. The single most confidently repeated fact about the future of our galaxy, the one thing everyone thought they knew, turned out, on closer inspection, to be roughly a 1 in 50 outcome. To understand how something so settled could come apart so completely, you have to understand what makes this measurement so fiendishly hard, and the reason is quietly profound. Measuring how fast Andromeda approaches us along our line of sight is relatively easy, because that motion squeezes its light toward the blue and we can read it directly. But whether the two galaxies actually collide does not depend only on that head-on motion. It depends on Andromeda's sideways motion, its drift across our line of sight, and that sideways motion is extraordinarily difficult to detect. It is the difference between a car driving straight at you and a car that will slide just past your shoulder. From 2.5 million light-years away, Andromeda's sideways creep across the sky over years of observation is so tiny that measuring it pushes our instruments to their absolute limits. And that single hard-to-catch number is the one that decides whether the galaxies meet head-on or swing past each other and miss. When the Sewala team accounted honestly for the uncertainty in that sideways motion, the range of possible futures spread wide open. At one edge of the measurement's uncertainty, the collision probability climbed above 90%, a near-certain merger. At the other edge, it dropped almost to zero, a clean miss with the galaxies sailing past each other into the far future. The truth sits somewhere in that range, and we cannot yet say where, which is exactly why the honest answer is no longer a date but a coin flip. And there was more. The old predictions had mostly treated the Milky Way and Andromeda as if they were alone, two objects falling toward each other in an empty room. But they are not alone, they have companions, and those companions pull. When the team included the Large Magellanic Cloud, a substantial satellite galaxy of our own, with about 15% of the Milky Way's mass, its gravity tugged our galaxy in a direction roughly sideways to the line toward Andromeda, nudging us off the collision course and lowering the odds of a merger. When they included the Triangulum Galaxy, another sizable member of the Local Group, its influence pulled the other way and raised the odds. The fate of our entire galaxy, it turns out, is balanced on the competing gravitational whispers of its smaller neighbours, a balance so fine that we cannot yet call which way it tips. It is worth understanding what the Gaia mission actually did, because it is one of the quiet triumphs of the grain of dust, and it is the reason we could even attempt this. Gaia is a space telescope that spent years doing one patient thing, measuring the exact positions of more than 1 billion stars, over and over, with a precision so fine it is hard to describe. To catch a star's tiny sideways drift, Gaia had to detect angular shifts comparable to seeing the width of a human hair from thousands of miles away, and it had to do it for over 1 billion stars at once, building a 3-dimensional map of our galaxy and its neighbours in motion. When you point that kind of instrument at Andromeda and watch how its stars, on average, creep across the sky over years, you can begin to extract the one number that had eluded everyone, the sideways component of its motion, and even with the finest star-mapping machine our species has ever built, that number remains so small and so hard to pin down that its uncertainty is enough to swing the fate of our galaxy from near-certain collision to clean miss. I want to head off a suspicious thought here, because some people, hearing that the experts changed their story, conclude that the experts never really knew anything, or that the whole edifice of cosmic distances is guesswork we should not trust. That is exactly the wrong lesson, and the reason is worth stating plainly. The distance to Andromeda is not a single guess. It is a number confirmed by several independent methods that have no reason to agree unless they are all tracking something real. There are the pulsing Cepheid stars Hubble first used. There is a separate kind of standard brightness star that gives the same answer. There is the direct geometric method of parallax, the same triangulation a surveyor uses, extended to the stars by missions like Gaia. These methods rest on different physics and different assumptions, and they converge on the same distance. When independent roads all arrive at the same town, the town is almost certainly there. The collision estimate changed not because the distances are shaky, but because one particular quantity, the sideways motion, sits right at the edge of what we can measure. An honest scientist said so out loud. One of the researchers summarized it with a line I find quietly wonderful. He said that proclamations of the impending demise of our galaxy seem greatly exaggerated. And I want you to notice what just happened, because it is the beating center of tonight. The reason this is not simply an astronomy lesson. For decades, we told ourselves a confident story about our galaxy's future. It was dramatic, specific, and repeated everywhere until it hardened into common knowledge. And when we finally measured carefully enough, the story dissolved, not into a scarier story, but into honest uncertainty. The certainty was the illusion. The universe did not owe us a clean ending, and when we looked closely, it did not give us one. This is the same movement we have watched all night, now applied to time instead of space. We assumed we were central, and we were not. We assumed our galaxy was the biggest thing around, and it was not. We assumed we knew how our galaxy's story ends, and we did not. Every confident claim about our own importance, our own position, our own destiny, has shrunk when examined closely. And here is the emotional weight of it, the second real pillar of the night. There is a particular kind of loss in this moment, subtler than the others. It is not just that our galaxy is small or off-center or invisible. It is that even the one grand fact we were sure of, even our own foretold ending, was told with more confidence than the truth could support. The security of a known fate, of at least understanding where the story goes, comes loose in your hands the way the other certainties did. We do not even get to keep our doom. And yet, listen to how this loss arrived, because the manner of it carries the answer we are building toward. Nobody hid the old prediction, and nobody hid its unravelling. The confident collision was published openly, taught openly, celebrated openly, and then the doubt was published just as openly in a major journal for anyone to read. This is worth pausing on, because there are people who would tell you that scientists conceal the truth, that the real dangers or the real answers are being kept from you. But watch what actually happened here. The science publicly reduced the certainty of its own most famous prediction. A field that was hiding the truth would not do that. It would not stand up and say, "We were more sure than we should have been, here is the honest uncertainty." This self-correction, out in the open, is precisely the signature of a process that is trying to be honest rather than trying to comfort you. The distances we measure to Andromeda, checked and rechecked by independent methods, and the fate we assign it, revised in public when the data demands it, are not stories handed down to keep you docile. They are our best current guesses, openly shown, openly corrected. That openness is going to matter enormously when we reach the strangest and most humbling parts of the night, because it is the reason we can trust the smallness even when it frightens us. So we arrive at the far edge of what one galaxy can teach us, and we arrive there humbled twice over. Andromeda is larger than our galaxy, and older, and unreachable, and falling toward us in a way that may or may not ever bring the two of us together. Even that, even the ending, we do not get to know for certain. If this is how uncertain and how humbling the story becomes when we look at the single nearest large galaxy to our own, one step up from home, then a natural dread begins to form about what happens when we stop looking at one galaxy and start pulling the camera back. Because Andromeda and the Milky Way, these two great wheels of hundreds of billions and a trillion stars, this pair whose meeting or missing we cannot even predict, are not the scene. They are two specks in a far larger structure, and it is time to pull back and see the room they are floating in. Part 7. One step back into the local group. Let us pull back now, slowly, the way a camera rises away from a single lit window until you can see the whole city around it. We have been standing very close to two galaxies, the Milky Way and Andromeda, treating them as though they were the entire scene. Now we lift up and away, and the two great spirals shrink toward each other until they are just two bright points in a larger gathering. That gathering has a name. It is called the Local Group, and it is the true neighborhood we live in, the smallest structure large enough to deserve the word cosmic. The Local Group is a collection of galaxies bound together by their mutual gravity, drifting through space as a single loose family, and it stretches about 10 million light-years across. 10 million light-years to hold the neighborhood that itself took us all night to reach the edge of. Take a slow breath and let yourself drift out into that space, because it is one of the quietest places imaginable, and there is a kind of rest in picturing it. Between the Milky Way and Andromeda lies 2.5 million light-years of almost perfect emptiness. Not a road, not a bridge, not a scattering of way stations, just an immense, dark, near-total nothing, threaded here and there by the faint gravity that binds the two galaxies together. If you floated in the middle of that gap, halfway between the two great spirals, you would see them as two soft ovals of light, one on either side, each holding hundreds of billions of stars, and between them, around you, in every direction, only darkness and the distant grain of other galaxies. It is not a frightening emptiness. It is a still one, the kind of silence that a drifting mind can sink into. Let yourself hang there for a moment in the imagined dark, between the two largest things in our local universe, with all that gentle emptiness holding you. Now notice who else shares this neighborhood, because the census is humbling in its own quiet way. The local group contains not 2 galaxies, but something like 80 or more, and yet almost all of that membership is made of dwarves, small dim galaxies that would fit many times over inside either of the 2 giants. The Milky Way and Andromeda are the 2 dominant members, and everything else, the more than 75 other known galaxies, are minor players, small satellites, and faint stragglers caught in the gravity of the 2 big wheels. Our galaxy, and its large neighbour, are the heavyweights of a neighbourhood that is otherwise made almost entirely of small change. And remember, within our galaxy, we are not central. We are on a minor arm, far out. So follow the chain of it carefully. We are a grain of dust around an ordinary star on a minor arm in the smaller of the 2 large galaxies, in a group of 80 that is mostly dwarfs. Each link in that chain makes us smaller, and we have only just begun to climb. There is one property of the local group worth holding on to, because it will matter enormously by the end of the night. The local group is gravitationally bound. That means the galaxies in it are held together tightly enough that the expansion of the universe cannot pull them apart. Everywhere else in the cosmos, on the larger scales, galaxies are rushing away from one another as space itself stretches. But within a bound group like ours, gravity wins locally, and the members stay together, orbiting and falling and perhaps merging, while the rest of the universe recedes into the distance. So this quiet family of 80 galaxies is, in a real sense, our permanent home. It is the largest structure we will always be able to see up close, the one island that will not drift away from us as the ages pass. Everything beyond it is, slowly, leaving. That is a strange and lonely fact, and we will come back to what it means for a creature trying to understand its place. For now, hold it lightly. Our neighborhood is bound. The rest is departing. Let yourself drift a while longer in that in-between space, because it is the kind of emptiness worth resting inside on a night like this. Picture the slow float outward from the Milky Way, its bright disk shrinking behind you, until you are far enough that our whole galaxy has become one soft oval, and Andromeda hangs as another, the 2 of them like 2 lamps at the far ends of an enormous dark room. Between and around them, scattered thinly, are the dwarfs, the small dim satellite galaxies, some of them so faint and sparse they are little more than loose swarms of a few million stars drifting in the gravitational current of the 2 giants. There is no sound out here, no wind, no sense of speed, only the 2 great lamps and the scattered small ones and the profound stillness of a neighborhood that measures 10 million light-years across and holds, in all that room, only a few dozen genuine members. Space at this scale is not crowded. It is almost unimaginably open. A few islands of light adrift in a darkness that goes on far beyond them. Take the census of this neighborhood slowly, because it too is humbling. Beyond the Milky Way and Andromeda, the next largest member is the Triangulum galaxy, a modest spiral perhaps 1/10 of Andromeda's mass, and after that the drop-off is steep. Everything else, the more than 70 other known members, is a dwarf. Some orbit the Milky Way, like the 2 Magellanic clouds visible from the southern hemisphere. Some orbit Andromeda, some drift more freely, and astronomers keep finding more of them, faint smudges of a few thousand or few million stars that had escaped notice, because dwarf galaxies are dim and easily lost against the background. So the true membership of our neighborhood is not a fixed and finished list. It is a slowly lengthening one, and almost every new entry is another small faint thing we had simply failed to see, which is a pattern you may be starting to recognise, because it will return, much larger, before the night is done. Consider how the meaning of the word everything has quietly collapsed over and over in just a few steps tonight. When you were a child, everything meant the earth and the sky above it. Then everything meant the solar system, the sun and its planets. Then it meant the Milky Way, the whole river of stars. Then Andromeda arrived and everything had to stretch to include another galaxy larger than our own. And now even the Local Group, this 10 million light-year family of 80 galaxies, is about to become a single small dot in something far larger. The word everything has been a balloon we keep having to inflate, and every time we inflate it, we ourselves become a smaller and smaller mark inside it. That is the vertigo we are climbing into, and it is important to feel it not as a fact but as a motion, a floor that keeps dropping just when you thought you had found the bottom. Notice how empty even this bound little family is, because the emptiness scales with everything else. Our galaxy is about 100,000 light-years across, and the gap to Andromeda is 2.5 million light-years, so the space between the two giants is more than 20 times the width of a whole galaxy, filled with almost nothing. If you shrank the Milky Way to the size of a dinner plate, Andromeda would be another plate more than 2 feet away, and between them, across all that distance, only a thin scattering of crumbs, the dwarf galaxies, and otherwise bare table. That is the true density of our neighbourhood. It is not a cluster of galaxies packed shoulder to shoulder. It is a handful of islands separated by oceans of dark, and we live on a minor arm of one of the two largest islands, which is itself a mostly empty wheel of stars held apart by their own enormous gaps. Emptiness is the rule at every level we have climbed tonight, from the space between stars to the space between galaxies, and we are a speck adrift in the middle of all of it. And remember what is happening to everything beyond this bound family, because it sharpens the loneliness of our position. The Local Group holds together, but the rest of the universe is receding, carried away by the expansion of space itself, and that expansion is speeding up. Given enough time, the galaxies beyond our bound neighbourhood will drift so far and so fast that their light can no longer reach us at all, and the sky will slowly empty of everything except our own merged family of stars. A creature living in that far future, looking out, would see only its own island and past it, an apparently endless dark, and it might reasonably conclude that its island was the whole of creation. We happen to live early enough to still see the crowded cosmos, to still count the trillions of galaxies. But even that fullness of the sky is temporary, and it is quietly leaving, sealing us in a little more with every passing age. And here is the thing to brace for as we prepare to pull back again. So far, every step outward has still kept us inside things we can name and picture. A galaxy, a pair of galaxies, a group of 80. These are large, but they are graspable. The next step out leaves the graspable behind. When we rise above the Local Group and look at the structure it belongs to, and then above that, and then out to the limit of everything we can see, the numbers stop being quantities you can hold in your mind and become something more like a tide you simply stand under. We are going to meet a number tonight that has been growing for 100 years, that grows every time we build a better telescope, and that has never once been revised downward. It is the number of galaxies in the universe we can see, and each time that number has grown, the size of the thing you are measured against it has shrunk. So take one more moment here in the quiet bound neighbourhood of the Local Group, this family of 80 that will always be ours, before we step out past the last thing that will ever feel like home, and into a count so large it stops meaning anything the mind can feel, except, perhaps, a kind of falling. Part 8. The number that keeps growing. When we rise above the Local Group, the first thing we find is that our little family of 80 galaxies is itself just one member of a far larger association, and then that association turns out to be part of something larger still. Our Local Group sits at the outskirts of an enormous flattened collection of thousands of galaxies, and that collection is only one lobe of a truly immense structure that astronomers mapped and named in 2014. They called it Laniakea, a Hawaiian word meaning immeasurable heaven, and the name is close to honest. Laniakea is our home supercluster, and it stretches about 520 million light-years across. It contains roughly 100,000 galaxies, all of them gently streaming over cosmic time toward a common gravitational focus called the Great Attractor, a region so massive that it pulls our entire supercluster of 100,000 galaxies slowly toward it. Our Milky Way, our Andromeda, our whole-bound local group, is a single flake being carried along one filament of one supercluster among many. Let the ratios settle on you slowly, because this is where the numbers begin to lose their footing in the mind. We went from one galaxy, to a pair, to a group of 80, and now to a supercluster of 100,000. And Laniakea is not special. It is one supercluster among a great many, threaded together across the cosmos in an immense web of filaments and walls and empty voids, a structure that looks, when astronomers map it, almost like the branching of nerve cells or the delicate structure of foam, galaxies strung along bright threads with enormous dark hollows between them. Our 100,000 galaxy supercluster is one bright knot in that web, and the web goes on, farther than any telescope can follow, out to the limit of what light has had time to reach us. That limit has a size, and the size is one of the strangest numbers in science. The part of the universe we can observe, the sphere of everything whose light has had time to arrive since the beginning, is about 93 billion light-years across. It is not infinite, but it is a number the mind cannot truly hold. And the question everyone eventually asks is the one that matters most for tonight. How many galaxies are inside it? For a long time, the estimate was something like 100 to 200 billion galaxies, already an impossible figure. Then, in 2016, astronomers led by Christopher Constellation went back through the most careful long-exposure images we had and corrected the count sharply upward. They concluded that the observable universe contained something like 2 trillion galaxies. 2 trillion. The estimate had grown roughly tenfold in a single revision, and even that number is now under pressure, because newer analyses, counting the faint dwarf galaxies that cluster around larger ones, suggest the true figure may be higher still, possibly 6 trillion, possibly closer to 20 trillion. I want you to notice the direction of every one of those corrections, because the pattern is the whole point. The number of galaxies has been revised upward, and upward, and upward again, and it has never once been revised down. Every time we built a sharper instrument, every time we stared longer into a darker patch of sky, we found more galaxies than we expected, not fewer. There is a famous kind of image behind this, taken by pointing a great telescope at a patch of sky so small and so seemingly empty that it looked like nothing, a piece of black no wider than a grain of sand held at arm's length, and then simply collecting light from that nothing for days. And the nothing filled with galaxies. Thousands of them, in a speck of sky you would have sworn was empty, each one a wheel of 100 billion suns, and most of them so far away their light had been travelling for the better part of the age of the universe. There is no empty part of the sky. There is only sky we have not yet stared into long enough, and every time we do stare the count of everything grows, and the size of what we are measured against that count shrinks again. There is a single image that captures this better than any number, and it is worth describing in full because it is one of the most quietly staggering things our species has ever done. Some years ago, astronomers took the Hubble telescope and pointed it at a patch of sky that looked completely empty, a scrap of blackness so small you could cover it with a grain of sand held at arm's length, a piece of nothing chosen precisely because it seemed to contain nothing. And then they simply left the telescope staring at that nothing, gathering the faintest trickle of light for the equivalent of many days. When the image finally developed, the nothing was not empty. It was full of galaxies, thousands of them, crowded into that tiny scrap of dark spirals and ellipticals and strange young shapes, each one a city of 100 billion suns, and most of them so far away that their light had been travelling for the better part of the age of the universe to reach that lens. In a piece of sky you would have sworn was blank, thousands of galaxies. Multiply that scrap across the whole sphere of the sky, and you arrive at the trillions. Let the meaning of that settle, because it changes how you have to think about every dark patch overhead. There is no empty part of the sky. There is only sky we have not yet stared into long enough. Every time we have aimed a better instrument at an apparently blank stretch of darkness and waited, the darkness has filled with galaxies we did not know were there. That is why the count has only ever moved in one direction. It went from a few billion to a few 100 billion to 2 trillion in a single revision in 2016, and it is now being pushed higher still towards 6 trillion, perhaps 20 trillion, as we learn to count the faint dwarf galaxies that swarm around the larger ones. Not once, in the entire history of the question has the number been revised downward. Every improvement in our sight has found more, never less, and each new galaxy discovered makes the moat you're standing on a little smaller against the total. The universe has never once turned out to be smaller than we thought. It has only ever turned out to be larger and us smaller within it. There is a structure to how all these galaxies are arranged, and even the structure dwarfs us. Galaxies are not scattered at random. They gather along immense curved filaments and sheets, strung together like droplets on a spider's web, with enormous empty voids between the strands. Some of those voids hundreds of millions of light years across and nearly empty of galaxies altogether. Our own supercluster is one bright knot where several of these filaments meet, and the whole assembly of filaments and voids, mapped as far as our telescopes can reach, is sometimes called the cosmic web. It is the largest pattern that exists, the scaffolding on which every galaxy hangs, and our Milky Way, our Andromeda, our whole 10 million light-year neighbourhood, is a single droplet on a single strand of it. There is nothing larger to zoom out to. This is the final structure, and we are a mote within a droplet on its web. Try, for just a moment, to place yourself against 2 trillion galaxies, though the mind will slide off it, because the sliding is itself the lesson. If there are 2 trillion galaxies, and a typical galaxy holds 100 billion stars, then the number of stars in the observable universe is something like 200 billion trillion, a 2 followed by 23 zeros. That is more stars than there are grains of sand on every beach and in every desert on the entire Earth, by a wide margin. And around a great many of those stars, planets. And you are on one planet, around one star, which is one of a few hundred billion in the Milky Way, which is the smaller of 2 large galaxies, in a group of 80, at the edge of a supercluster of 100,000, which is one knot in a web of perhaps 2 trillion galaxies, and possibly 10 times more than that. Every clause in that sentence is a step down in significance, and there are 9 or 10 of them, stacked one atop another, and at the bottom of all of them, holding still under the whole weight, is you, listening in the dark. This is the vertigo the whole night has been climbing toward, and I do not want to rush you past it or console you out of it too quickly, because it is real, and it deserves to be felt. You are extraordinarily, almost incomprehensibly small. Not small the way a person is small next to a mountain, or even small the way the Earth is small next to the Sun. You're small in a way that requires a stack of 9 nested comparisons even to locate, each one shrinking you further until the word small stops being adequate and something quieter and stranger takes its place. And here, at the bottom of that stack, we finally arrive at the exact shape of the disturbing truth this whole journey was named for. It is not simply that the universe is large and we are small. We have all heard that our whole lives, and it has lost its power to move us. The truth is sharper and more personal than mere bigness, and to feel its real edge, we have to do one more thing. We have to go back to where we started, to Andromeda, the one other place close enough to feel like a neighbour, and we have to stand there, in our imagination, and turn around, and look for ourselves in the sky. Because what we will fail to see is the point of everything. Part 9. The View from Andromeda. Come with me across the gap now, in the only way we ever can, in imagination, and let us stand on the far side and look back. Picture that we are on a world somewhere in Andromeda, orbiting one of its trillion stars, on a clear night, under that galaxy's own crowded sky. We turn to face the direction of the Milky Way, 2.5 million light-years away, and we search for our home. And what we find, if we find anything at all, is a faint oval smudge low against the dark, a soft blur of light no more remarkable than the smudge of Andromeda looks from Earth. That blur is the entire Milky Way, every star you have ever seen with your naked eye, every star in every constellation, every one of the few thousand points humanity has named and mythologized, across all of history. All of them are compressed into that single dim smear, indistinguishable from one another, merged into one faint patch of grey. Now look harder. Somewhere in that smudge, buried among a few 100 billion other stars, is the sun. Try to find it. You cannot. It is not that it is dim. It is that it is utterly, completely lost, one ordinary star among hundreds of billions, far out on a minor arm, contributing an amount of light to that smudge so small it could never be separated from the whole. With an instrument like our finest telescope standing in Andromeda, you could not pick the sun out of the Milky Way's glow. And if you cannot find the sun, then you certainly cannot find the Earth, which shines with no light of its own, a speck of rock 100 times too faint and too close to its star to be seen at all across that gulf. Everything that has ever happened to our species, every empire and every love and every war and every idea, every person who has ever lived and died, all of it happened on a mote you cannot even locate inside a smudge that is barely visible from the nearest large galaxy. That is what our home looks like from next door. It looks like nothing. It looks like a faint grey oval with no detail at all. And here is the sentence the whole night has been walking toward. The one on the thumbnail, the one I want you to feel land now with its full weight. We are invisible, not small, invisible. There is a difference, and the difference is the entire point. To be small is still to be seen, to register, to be a tiny thing that nonetheless makes a mark. But from any real cosmic distance, we do not make a mark at all. Remember the bubble of our radio signals, everything we have ever broadcast, spreading out at the speed of light for a century, fading as it goes. That bubble is about 100 light-years across. The gap to Andromeda is 2.5 million light-years. Our loudest signal, the only evidence of our minds that has ever left the Earth, has crossed less than 1 part in 20,000 of the distance to that smudge, and it is already dissolving into static. If there were astronomers in Andromeda tonight, with instruments exactly as good as ours, pointing them directly at the Milky Way, they would see a spiral smudge of a few 100 billion stars, and they would have no way whatsoever to know that on a minor arm of that smudge, a species had arisen that measures galaxies and dreams of the stars. We would be, to them, entirely unseen. We are, to the universe at large, entirely unseen. Sit in that for a moment in the dark, because it is meant to be a hard place to sit, and rushing past it would cheat you of what comes after. There is a loneliness in true invisibility that is different from the loneliness of merely being small. A small thing can still be found. An invisible thing cannot even be looked for, because nothing knows to look. Every message we have ever sent, every attempt to announce ourselves, is a whisper 100 light-years wide in a cosmos of 2 trillion galaxies, and it fades before it clears the doorstep. We have spent a great deal of our history imagining that we are watched, that we matter to something out there, that our story is being witnessed. And the honest measurement says otherwise. The universe is not watching us. It cannot see us. We are a mote inside a smudge, inside a group, inside a supercluster, inside a web of trillions, broadcasting a signal that dies at the edge of our own street. This is the disturbing truth about our size, stated as plainly as it can be stated. It is not that we are little. It is that from anywhere that is not here, we cannot be found at all. Stay on that imagined world in Andromeda a little longer, and ask what those astronomers could learn about us even in principle, straining with every instrument they have. They could, if they were extraordinarily patient and fortunate, perhaps detect that the Milky Way's faint smudge held a certain kind of star, and around a few of those stars, the tiny rhythmic dimming of unseen planets crossing in front of them. If they aimed everything at exactly our star, which they could not actually pick out, they might in principle read the chemistry of our air in the filtered starlight and notice the strange pairing of oxygen and methane that hints at life. But all of that is a fantasy of perfect equipment trained on a target they cannot even locate. In practice, across 2.5 million light-years, the Earth is a speck of reflected light pressed against the glare of a star that is itself lost inside the glow of a smudge. The only honest, lasting sign that we exist at all is written in the chemistry of our thin shell of atmosphere, and it can be read only from close by someone who already knows precisely where to look, which no one out there does. There is a particular quiet that comes with fully absorbing this, and I want to let it stay quiet rather than rush to fix it. For most of human history we assumed the sky was full of eyes, gods or ancestors or watchers, and that our lives were seen and weighed by something above us. The measurement says the opposite, gently and without cruelty. The sky is not full of eyes turned toward us. From the nearest large galaxy we do not register at all. From anywhere farther we are less than a rumour. Whatever meaning our lives carry, we will not receive it from being watched by the cosmos, because the cosmos, for all its size, is not looking, and could not find us if it tried. That is a lonely thought, and it deserves a moment of honest silence before we do anything with it. We are not small figures on a stage before a great audience. We are alone in the dark, unwitnessed, holding a candle whose light dies at the edge of the room. Let me draw the distinction one more time as sharply as I can, because everything that follows turns on it. Being small is a relationship. A mouse is small beside an elephant, but the elephant can see the mouse, can step around it, can be startled by it. Smallness still leaves you inside the circle of things that register. Invisibility is a different condition entirely. Invisibility puts you outside the circle. It is not that the universe sees us and finds us tiny. It is that the universe has no way to see us at all, that every signal we have ever sent dies before it clears our own neighborhood, that our loudest evidence, a radio bubble 100 light-years across, would have to grow 20,000 times larger merely to reach the nearest big galaxy, and would arrive there as pure static even so. We have spent our whole existence assuming we're a small thing in a large room. The truth is stranger. We are a thing the room cannot detect, calling out into a silence that closes over us one step from our own door. I promised you at the very beginning that this smallness, held the right way, could open into something better than the comfort it takes away, and now, standing at the very bottom of the fall, we are finally close enough to that turn to feel it beginning. Because there is something odd about this whole picture, something that does not quite fit, and once you notice it, you cannot unnotice it. We have just described in careful detail how invisible we are. We have stood in imagination on a world in Andromeda, and confirmed that the sun cannot be seen, that the earth is lost, that our signals die at the doorstep. But stop and ask yourself, who is describing this? Who worked out how faint the sun would look from 2.5 million light-years away? Who measured the size of our own radio bubble and compared it to the gap and found it wanting? Who stood, in imagination, on that far world and turned around and looked back and understood exactly how invisible we are? We did. The invisible mote did. The thing that cannot be seen is the very thing that figured out that it cannot be seen, and mapped the whole immensity that hides it, and gave the immensity names, and that, it turns out, is not a small thing at all. In fact, it may be the least small thing in the entire 2 trillion galaxies. But to understand why, we have to turn the grain of dust back over in our hands and look at it again, this time not for how little it weighs, but for what, impossibly, it has done. Part 10. The only witness we know of. Return with me to the phrase I asked you to keep, the one I planted a few chapters back and told you we would need at the end. A grain of dust that can weigh a galaxy. All night we have been stacking up the ways in which we are the grain of dust, negligible, off-centre, invisible, unreachable. But that phrase has a second half, and the second half is not decoration. It is the answer. Because it is genuinely, staggeringly true that this grain of dust has weighed a galaxy. Consider again what that means, now that you can feel the size of the gap. Sitting on an invisible mote, inside a smudge that cannot be seen from the nearest large neighbour, a species with a lifespan of a few decades, that has never travelled beyond its own moon, worked out the mass of a black hole 2.5 million light-years away, at the centre of a galaxy it can never visit, using nothing but patient thought and the faint light that happened to fall on it. Nothing in the 2 trillion galaxies, so far as we know, has ever done anything remotely like that, except us. Let me put you inside the act of it, because we have stood inside our smallness tonight, and it is only fair to stand inside the other thing too. Picture a single human being at an instrument on an ordinary night. There is coffee going cold. There is the hum of a machine. On a screen, faint smudges of light, gathered over hours from a galaxy so far away, the light set out before there were people. And this one person, this warm, tired, mortal animal, takes those smudges and, with mathematics worked out by others who are already dead, turns them into a number. The number is the mass of the dark, unseeable object at the centre of Andromeda. It is somewhere between 100 million and 230 million times the mass of the Sun, and this person now holds that fact in their mind, a galaxy's hidden centre, resting inside a single quiet human thought, on a small world that the galaxy in question cannot even see. That is not nothing. That may be the most remarkable thing that happens anywhere in the reachable universe. The cosmos built something, out of its own dust, that could turn around and comprehend the cosmos, and as far as all our searching has found, it built that only once, and it is us. There is a temptation, standing here, to soften the loneliness with a hopeful thought, and it is worth voicing carefully, clearly marked as speculation rather than fact. Andromeda holds something like 1 trillion stars, 10 times our own galaxy's count, and around a great many of them surely are planets, If life arises anywhere the conditions allow it, then 1,000,000,000,000 stars is an enormous number of chances, and it becomes hard to believe that in all that immensity across a galaxy older and more settled than our own, life never once stirred. Perhaps it did. Perhaps in the billions of years Andromeda has slowly turned, creatures arose there, looked up at a faint smudge in their own night that happened to be the young Milky Way, wondered as we are wondering, and were gone before the Earth had finished forming. We cannot know. It is a guess dressed in large numbers, and honesty requires me to call it exactly that. But notice something. Even if Andromeda once teemed with life, even if the universe is crowded with living worlds, the particular thing we have been marvelling at tonight might still be rare. Life may be common. Understanding, the kind that weighs a black hole across 2.5 million light-years, may be almost vanishingly uncommon. We do not know of a single other instance of it anywhere. Look at what the universe mostly is, and the rarity comes into focus. It is overwhelmingly hydrogen and helium, cold and dark and unthinking, spread thin across gulfs that light takes billions of years to cross. It is stars that burn without knowing they burn, and black holes that pull without knowing they pull, and 2 trillion galaxies wheeling through their slow, gravitational choreography with no one, in almost every one of them, to notice. That is the default condition of things. Matter doing what matter does in silence. And then, in one thin film on the surface of one small world, on one minor arm of one ordinary galaxy, the matter did something it appears to do almost nowhere else. It arranged itself into patterns that could ask questions. It grew curious about itself. It looked up and began to measure. Set against the immense, patient unconsciousness of nearly everything, that is not a small event. It may be the least likely and most astonishing thing that has ever happened, and you are inside it, doing it, right now, in the dark. So hold the two truths together now, both at full strength, because neither cancels the other, and the whole meaning of the night lives in their tension. We are negligible. By every physical measure, size, mass, brightness, reach, we round to nothing. A mote inside a smudge inside a web of trillions, invisible from the very next galaxy over, and we are, at the same time, the only part of all that immensity known to have understood any of it. The universe is almost entirely large, dead, and unseeing. The tiniest sliver of it, on one invisible speck, has woken up and started keeping track, measuring the distances, weighing the black holes, mapping the web, even predicting and then honestly correcting the fate of its own galaxy. Awareness, not size, turns out to be the rare and precious thing. There is a great deal of size in the universe. Size is cheap. 2 trillion galaxies worth of it. What is not cheap, what may be almost unique, is a stretch of matter that has arranged itself into something that can know it is here, and grieve that it is small, and go on measuring anyway. Notice that the grief had to come first. If someone simply tells you not to worry, that you matter, that your smallness is fine, the words slide off, because they are cheap the way size is cheap. But we did not take the cheap road tonight. We went all the way down. We stood on a world in Andromeda and confirmed in detail that we cannot be seen. We stacked the 9 nested comparisons and felt each one shrink us. We let even our galaxy's grand foretold ending come loose into a coin flip. We earned the smallness honestly, all the way to the bottom, and it is only from that bottom, having refused every easy comfort, that the real thing becomes visible, and it does not feel like a consolation prize. It feels like the plain truth, sitting there the whole time. The invisible mote is the eye the universe grew to look at itself. You are not separate from the immensity staring up at it as an outsider. You are the immensity, folded briefly into a shape that can wonder. The atoms in your body were forged inside stars and scattered by their deaths. And here they are, gathered for a moment into something that can look up at other stars and understand where it came from. The universe is not watching you. But through you, faintly, briefly, it is beginning to watch itself. Trace the chain that had to hold for that measuring mind to exist at all, because its improbability is part of its worth. The universe began hot and formless and cooled, and the first stars had to ignite and live and die to forge the heavier elements, the carbon and oxygen and iron that did not exist in the beginning, because the beginning made almost nothing but hydrogen and helium. Those first stars had to explode and scatter their new elements back into space. That enriched material had to gather again into new stars and planets, one of which had to sit at the right distance from a steady star and hold liquid water and stay stable for billions of years while, on its surface, matter fumbled its way from simple chemistry to living cells to minds. Every link in that chain was necessary, and every link took an immensity of time, and the whole long sequence produced on this one world a creature that could turn around and reconstruct the entire chain, including the part about the exploding stars from the faint light of a galaxy it will never touch. You are the far end of that chain. The universe spent 13.8 billion years assembling something that could understand it, and you are a working example of the result. There is a plain dignity in being that, and it does not require you to be large. A candle does not have to fill a cathedral to be the only light burning in it. In a universe of cold and silent immensity, a small, warm, temporary thing that understands is not diminished by the darkness around it. If anything, the darkness is exactly what gives the small light its whole meaning. You're not in competition with the galaxies for size, a competition you would lose instantly and completely. You're doing the one thing the galaxies, for all their grandeur, cannot do. You're noticing that they are there, and that noticing, brief and local and invisible as it is, may be the closest thing to a purpose that any of the measurements have left standing. That reframing does not make us large. Let me be honest, because honesty is the only currency that has bought us anything tonight. We are still a mote. We are still invisible from Andromeda. The measurement of our insignificance stands, every number of it intact. What has changed is not the size of the thing we are, but the value we have learned to place on the strange, improbable fact of our awareness, which no amount of size can buy, and which the whole rest of the observable universe appears, so far, to lack. And once you hold that, once you feel that the rare thing is not to be big but to be aware, you can look back at that faint smudge in the autumn sky with entirely different eyes. Because Andromeda is not only the mirror that showed us how small we are, it is also, when you look at it correctly, one of the most extraordinary things a conscious being can lay eyes on, and understanding why requires us to think, one last time, about the strangest property of its light. Part 11. The light that holds past and future. The light from Andromeda that lands in your eye tonight is 2.5 million years old, and that single fact folds time in a way worth holding gently as we come toward the end. When you look at that smudge, you are not seeing Andromeda as it is. You are seeing Andromeda as it was 2.5 million years ago, when our own ancestors were small, upright creatures on the plains of Africa who had only just begun to shape stone. The galaxy you are looking at is a photograph, developed across 2.5 million years of travel, and the thing it shows you no longer exists in that exact form. Its stars have moved on, some have died, new ones have lit. Whatever is truly happening in Andromeda right now, tonight, we will not see for another 2.5 million years, and no human alive tonight, and perhaps no human at all, will ever see it. To look up at that smudge is to look, quite literally, into the past, into a moment older than our species, still arriving, still faithfully delivering its ancient news to anyone who bothers to find it. Let yourself drift for a moment on that idea, because it is one of the gentlest and strangest truths in all of astronomy, and it makes a soft place to rest near the end of a long night. Every light in the sky is a message from a different moment in the past. The moon you see is a little over a second old. The sunlight on your skin left the sun 8 minutes ago. The nearest stars show you years and decades gone by. The centre of our own galaxy is 27,000 years old by the time its light reaches you, and Andromeda is 2.5 million years old, the furthest back your unaided eye can ever reach. The night sky is not a picture of now. It is a layered archive of then, the near things recent, the far things ancient, all of it arriving together in a single quiet moment inside your eye, so that when you lie back and look up, you're reading a document written across millions of years, all its pages delivered at once. There is nothing to do with that fact but feel it. It asks nothing of you. It is simply true, and it is simply strange, and it has been waiting over your head your entire life. Let the layering of the sky's past unfold slowly, because it is a gentle thing to rest your mind on as the night grows late. Look up on a clear night, and every point of light is showing you a different moment in history, all of them arriving together in a single glance. The moon shows you a little over a second ago. The planets show you minutes to hours ago. The bright nearby stars show you years, decades, a few centuries gone. The stars of a familiar constellation are not neighbours at all, but a chance alignment of lights from many different distances and many different eras, some of them from stars that have already died in the time their light has been crossing to you, so that the pattern you know by name is partly a memorial, a shape held together only by the slowness of light. Farther out, the soft band of our own galaxy shows you thousands of years, and past all of it, that one faint oval shows you 2.5 million years, the furthest into the past your unaided eye can ever reach. The night sky is not a scene, it is a stack of moments, the near ones recent and the far ones ancient, delivered all at once into one upward look. There is a tenderness in that if you let yourself feel it. Every particle of light reaching your eye from that smudge has been travelling, untouched, for 2.5 million years, across an emptiness so complete that nothing interrupted it, until the final instant of its enormous journey, when it ended inside you and became a small flash of seeing. It did not cross all that darkness in order to be useful. It crossed it to be caught, and you are the catching. When you lie back under that ancient light, you are the place all of it has been falling toward, the destination of a journey that began before your species did. There is a strange closeness in that, an entire galaxy's ancient light ending its travels in the quiet dark of a single human eye on one cold night, for no reason at all except that you looked up and were patient enough to receive it. Consider that even this ability to read time in the light is a recent and hard-won thing, one more quiet feat of the grain of dust. For almost all of history, people looked at the stars and assumed they were seeing the present. A fixed dome of lights hung overhead, all at the same instant, all at the same distance. The idea that light travels at a finite speed, that the sky is therefore a record of the past, that different stars are showing us different eras, none of this was obvious, and all of it had to be measured and reasoned out across centuries by small mortal creatures who would never travel to a single one of those stars. We worked out the speed of light, we worked out the distances, and from those two things we taught ourselves to read the night sky as a document written across millions of years, and to know, when we look at that smudge, exactly how far back into time we're seeing. That is not a small inheritance. It is one more thing the invisible mote learned to do, sitting in the dark, refusing to look away. But Andromeda's light does not only show you the past. If you look at it correctly, it also shows you a possible version of your own future, and this is what makes that smudge more than a museum piece. Because Andromeda may, or may not, one day merge with our galaxy, and whatever the two of them become, it is the kind of ending our own galaxy is drifting toward, whether with Andromeda or with time alone. And meanwhile, on a far shorter clock our own small stage is quietly being struck. Long before any galaxies meet or miss, our own sun is slowly brightening. In roughly 1 billion years the sun will be about 10% brighter than it is today, enough to push the Earth past a threshold from which there is no easy return, boiling away the oceans in a runaway heat that ends the era of liquid water, and, with it, the era of life as we have known it. By the time any galactic collision could even begin, 4 or 5 billion years out, the sun may be 40% brighter, and the Earth will long since have become a scorched and silent rock. So when you look at that smudge and imagine the grand merger of galaxies, understand that our own part in the story ends far sooner and far more quietly, not in a collision of galaxies, but in the gradual warming of a single ordinary star. We are not only tiny in space, we are brief in time. Our whole moment is a short one, bracketed on both sides by a darkness we cannot enter. Let me slow down on that shorter clock for a moment, because it is the part of our smallness that touches us most directly. Our sun is a stable star, but it is not a constant one. It has been slowly brightening across its whole life, as helium ash builds up in its core and it burns a little hotter to compensate, and it will keep brightening whether or not any galaxies ever meet. In roughly 1 billion years, the sun will be about 10% brighter than it is today, and that is enough to tip the Earth's climate past a threshold, warming the oceans until water vapour floods the air, and the water vapour traps still more heat, until the process runs away and the seas begin to boil off into space. Long before the sun swells into a red giant, long before any galactic encounter could even begin, the Earth will have become a dry, sterilized rock. The window for life on this world, already several billion years open, has perhaps another billion years left in it, maybe a little more. Measured against the galaxies we have been touring tonight, that is the blink of an eye. So place our whole story in its true frame before we turn toward home. The light from Andromeda takes 2.5 million years merely to reach us. Any merger of the galaxies is 4 or 5 billion years away, if it comes at all, and our own habitable moment, the entire span in which the Earth can hold life, is a thin sliver that will close long before any of that, ended not by a cosmic catastrophe, but by the ordinary gradual warming of a very ordinary star. We are not only a mote in space, we are a brief flicker in time, a species that has existed for a few 100,000 years on a world with perhaps 1 billion left, under a sky whose slowest events dwarf our whole existence into a single held breath. And yet here we are, inside the flicker, having somehow worked all of it out. And still, knowing all of that, the right response to that smudge is not despair, and here the callback completes itself, because the faint grey oval you could hide behind your thumbnail has become, over the course of one night, something enormous. It began as the least noticeable thing in the sky, a smear most people never find, and now you know that it holds 1 trillion suns, that it dwarfs your own galaxy, that it carries in its ancient light both a picture of the past older than humanity, and a hint of the far future our own galaxy is drifting toward. The same smudge. It did not change. You did. That is the quiet miracle folded into this whole long walk. Nothing out there moved. The only thing that changed tonight is what you understand, and that change transformed a forgettable smear into one of the most meaning-laden things a person can look at. The universe did not become larger or grander over the last 2 hours. Your comprehension of it did. And that comprehension, that slow turning of a smudge into a colossus into a mirror, is the very thing we said was rare. The thing the grain of dust can do that the immensity, for all its size, cannot. Part 12. The short moment the stage is ours. So let us go back, one last time, to where we began, to the dark field and the cold air and the faint smudge you almost could not find. Nothing about that view has changed in the last 2 hours. The photons are still arriving the way they always have, 2.5 million years in flight, ending in the small darkness of your eye. What has changed is the person doing the looking, and that turns out to be the only thing that was ever going to change. You came out to the field carrying a quiet, unexamined sense of your own size, the ordinary human assumption that you are, more or less, at the centre of a world that more or less noticed you, and you are leaving it knowing that you are a mote on a mote on a mote, invisible from the nearest large galaxy, adrift in a web of 2 trillion galaxies, brief as a single warm breath in a cold and enormous night. That is the disturbing truth the whole journey was named for, and we did not soften it. We let it be exactly as large as it is. But we also found the thing that sits on the other side of it, the thing you can only reach by going all the way through the smallness rather than around it. We are invisible, yes. From anywhere that is not here, no one could find us, no instrument could catch us, our loudest signal dies at the edge of our own doorstep. And we are, at the very same time, the part of all this immensity that turned around and saw itself. We are the invisible thing that mapped the immensity that hides it. Those two facts do not fight each other. They are the same fact seen from 2 sides. To be small enough to vanish, and aware enough to know it, and to keep measuring anyway, calmly, honestly correcting yourself when the data demands it, that is not a defeat. As far as everything we have ever been able to see can tell us, it is the rarest event in the known universe. Size is everywhere. There are 2 trillion galaxies of it. A watcher is, so far, almost nowhere, and you are one, tonight, lying in the dark, letting a voice carry you through the shape of your own smallness without flinching from it. There is a particular dignity in that, and it is a quiet one, the kind that does not need anyone else to witness it in order to be real. The universe is not watching you. That was the frightening discovery. But you are watching the universe, and that, it turns out, is the more remarkable direction for the watching to run. A rock does not know it is small. A star does not know it is large. Only a thing like you, briefly, improbably, knows anything at all, and can look up at a smudge in the sky and feel the whole immensity press down and, instead of being crushed, understand it. The stage is enormous and old and mostly empty, and it will go on for a length of time that makes our whole species a flicker. And for one short moment, on one invisible speck, the stage is ours, and we are awake on it, and we are paying attention. That is not nothing. Given how the rest of the 2 trillion galaxies appear to spend their time, it may be very close to everything. I want to be careful not to hand you a tidy moral here, because the truth we found tonight is not tidy, and pretending otherwise would betray it. We did not discover that we secretly matter after all, that the smallness was a trick and we are important really. The smallness is real. Every number of it stands unchanged in the dark. What we discovered is subtler, and I think sturdier, than a reassurance. We discovered that two opposite things are true at the same time, and that neither one erases the other. We are physically negligible, invisible from the nearest galaxy, brief as a single breath. And we are the only part of this whole immensity we have ever found that knows the immensity is there. You do not have to choose between those. You are not asked to feel either enormous or worthless. You are asked, I think, only to hold both at once, steadily, the way you might hold two stones of different weights, one in each hand, and feel the balance between them, and understand that the balance itself is the truest thing about your place in the universe. And if you can hold both, something quietly shifts in what it means to pay attention at all. Every act of noticing the universe, of learning one more true thing about it, of lying in the dark and letting a fact about a distant galaxy genuinely land, becomes a small instance of the rarest event we know of, the cosmos coming to consciousness of itself through one of its own tiny, temporary parts. You do not have to travel to Andromeda to take part in that. You are taking part in it right now simply by understanding what that smudge really is. The stage is enormous and old and mostly silent, and for a short while it is ours, and the only thing it has ever asked of us, the only thing that was ever in our power to give, is that we stay awake on it, and look, and understand what little we can while the looking lasts. So the next time you're somewhere truly dark, in the cold, with the stars laid out like powder across the whole sky, I hope you will do one thing. I hope you will find the little W of Cassiopeia and follow it down and across until you land on that faint grey oval that almost nobody ever finds. And I hope that when you find it, you will feel both halves of what it means at once. You will be looking at the largest and oldest thing your eyes can reach, a wheel of 1 trillion suns, larger than your whole galaxy, falling toward you across a gap you can never cross, its light 2.5 million years old, and you will be looking at it out of a pair of eyes belonging to a creature so small that from that very smudge you cannot be seen at all. The largest thing you can see and the smallest thing that can see. Both, in one quiet glance, on one cold night, while the light that left before you existed finishes its long journey home inside you. Before we let the night go, hold the two images side by side one final time, because together they are the whole of what we found. On one side, the largest thing your eyes can reach, a wheel of 1 trillion suns, 220,000 light-years across, falling toward you over a gap that not even light can cross in less than 2.5 million years, so far away and so enormous that it shrinks to a smudge you could hide behind your thumbnail. On the other side, the smallest thing in this whole story that can see anything at all, a soft, warm, short-lived creature on an invisible speck, who nonetheless found that smudge and measured it and understood it and felt correctly, both how small it is and how strange it is that it can know. The largest thing that can be seen and the smallest thing that can see. Neither one is more true than the other. They are the two ends of a single quiet miracle, and tonight, for a little while, you have held both. There is a reason we did not rush to this comfort, and it is the same reason the comfort holds. If someone had simply told you at the start of the night that you matter, that your smallness is nothing to fear, the words would have slid off because they had not been earned. Instead, we went down, all the way down, past the smaller galaxy, and the minor arm and the coin flip fate and the total invisibility, and we refused every easy handhold on the way, and only at the very bottom, having taken the smallness completely seriously, did the other thing become visible, sitting there the whole time, waiting to be found. That is why it holds. It is not a comfort offered in place of the truth. It is a second truth, resting underneath the first, that the first one could never on its own reach. That is where we will leave it tonight, not with an answer tied off neatly, but with a smudge in the sky and a question you can carry back down out of the dark. If the rarest thing in all the immensity is a small, brief, invisible watcher who understands, then what exactly is such a watcher for? We have measured the galaxies, we have weighed the black holes, we have found ourselves to be almost nothing, and found the finding itself to be almost everything. What we have not done, what no one has yet done, is say what we ought to do with the short, astonishing moment of being the eye, the universe grew to see itself? That is not a question for tonight. Tonight was only for learning how small we are and how strange it is that we can know it. The rest of the question is yours to carry, out under that ancient light, for as long as the stage is ours.